Hello everyone, this is Ramachandran, math tutor from onlinemathforall.com. In this video, we are going to see the stuff for factoring with the difference of two squares, the concept and sample problems which are much required for digital SAT math. Okay, let's go to the stuff. Here we have an algebraic expression that is x squared negative 25. I want to factor this expression. Okay, let's see how this expression can be factored using a difference of two squares. For that, we have to consider an identity in algebra that is a square negative b square. Okay, here we have two squares and we find difference between them. So it's called difference of two squares. And whenever we have difference of two squares, it can be written in factored form, that is a positive b times a negative b. Okay, now to get the factor form of this expression, what I have to do is I have to write this expression exactly in this form, a square negative b square. Okay, the first one is already in the form of a square because it's a square one, and this one also is squared. Okay, now what we have to do is we have to write this 25 in the form of b square. Okay, now let me do it. That is x square negative 25 can be written as pi square because it's a perfect square. Okay, now this is exactly in this form, a square into b square. At the place of a, we have x, and at the place of b, we have 5. Since this is exactly in this form, it can be written in factor form like a positive b times a negative b. Okay, now we have to plug in x for a and 5 for b over here. Then I'm getting x positive 5 times x negative 5. Okay, here I got the factor form of this expression. Okay, let's look at the next example. Here we have the second example, that is we have to factor this expression 36x square negative 1. And the same thing what we have done in the previous example, that is we have to get this expression exactly in this form, a square negative b square. Then using the stuff that is a product of the two binomials a positive b and a negative b, we can get the factor form of this one. Okay, first let's get this one in this form, a square negative b square. Okay, in my first step what I'm going to do is I'm going to write this 36 as 6 square because 36 is a perfect square and it can be written as a 6 square, and we can write this x square as it is 6 square times x square negative, and we can write this 1 as 1 square. Okay, now I have made some changes in the given expression. Even if I simplify this one, it must be equal to the original stuff, that is 36x square negative 1. We know that the value of 6 square is 36. We get 36 times x square, that is first term. And we have negative sign over here. Here we have negative sign. When I evaluate the value of 1 square, it's still equal to 1. So the stuff I got over here, it's equal to the original expression. Okay, here two quantities are multiplied with the same exponent. Whenever two powers are multiplied with the same exponent, what we can do is we can take the exponent in common. That is, we can multiply the bases 6 times x, and we can write this exponent 2 in common, negative 1 square. Now, this expression is exactly in this form, a square into b square. At the place of a, we have 6x, and at the place of b, we have 1. Okay, now to get the factor form of this expression, we have to consider the product of the two binomials over here. Now, in this one, we have to plug in 6x for a and 1 for b. We get 6x positive 1 times 6x negative 1. Okay, here I got the factor form of the expression 36x square negative 1. Let's look at the next example. Here we have the next problem, that is we have to factor this expression. The same thing we have to do it, that is we have to get this expression exactly in this form, a square negative b square. We know that 16 is a perfect square, it can be written as a 4 square. But this one cannot be written as a square. We have odd exponent over here. When we have even exponent over here, we can write this one as a square. Now, let's consider both the terms of this expression. There is a common divisor x for both the terms. We can factor x out. When x is factored out, to get the stuff inside the parentheses, we have to divide both the terms of this expression by the one I factored. That is, I have to divide it by x. When I divide this one by x, I am getting 16 times x to the fourth power negative. When I divide this one by x, I am getting 81. Okay, now x times, here 16 is a perfect square, and here we have an even exponent. It can be written as a square. 81 is a perfect square. It can be written as 9 square. Okay, first we can write this 16 as a 4 square, and this x to the fourth power can be written as x square the whole square. Actually, a power is raised to another power. Whenever a power is raised to another power, we can multiply the two exponents. When I multiply these two exponents, 2 and 2, that is 2 times 2, that is equal to 4. So the simplified form of this stuff is x to the fourth power. Okay, so whatever stuff I have written over here, it is equal to 16 times x to the fourth power. Negative 81 is a perfect square. It can be written as a 9 square. Now x times, now two powers are multiplied with the same exponent. Whenever two powers are multiplied with the same exponent, we can write this exponent 2 in common. That is, we have to multiply the two bases 4 and x square. Let me write it. And we have to write this exponent in common, 4x square the whole square, negative 9 square. Now, let's consider the stuff inside the square bracket over here. It is exactly in this form, a square negative b square. At the place of a, we have 4x square. At the place of b, we have 9. Okay, now it can be written in factored form. We have to use the product of two binomials. At the place of a, we have to plug in 4x square, and at the place of b, we have to plug in 9. And for a negative b, we have 4x square negative 9. Okay, x times this expression cannot be factored anymore. We have to write this one as it is, positive 9. And this expression can be factored further using the same algebraic identity, that is a square negative b square. For that, we have to write this expression in this form. Okay, we know that 4 is a perfect square. It can be written as 2 square times x square. 9 is a perfect square. It can be written as 3 square. Okay, let me continue over here. X times 4x square positive 9 times and here two powers are multiplied with the same exponent too. We can multiply the bases and take exponent in common. Then we get 2x whole square negative 3 square, and x times 4x square positive 9 times this expression is exactly in this form. At the place of a, we have 2x. At the place of b, we have 3. So we can write this one in factored form, like a positive b times a negative b. For a, we have to plug in 2x, and for b, we have to plug in 3. 2x positive 3 times a negative means a negative b means 2x negative 3. Okay, here I got the factor form of the given expression. Okay, let's look at the next problem. Here we have the next problem. This question is not about factoring, it's about simplification. That is, we have to simplify the expression we have over here. Okay, let's see how this expression can be simplified using the identity we have over here. That is a difference of two squares in factor form. Okay, now let me take the expression in numerator. We have x square and negative. It's almost in this form, a square negative b square. But the first one is okay. It's in the form of a square. The second one is not in the form of b square. And also this 41 is not a perfect square, but it must be written in the form b square. How do you have to do that? Okay, here we have 41. For 41, we don't have square, but I need square for 41, so that it can be considered as a b square over here. Okay, whenever I need square for some stuff, but it's not a perfect square, what I have to do is I have to take square root of for that number. Now I have to square this one. Now when I evaluate the value of this one, it is equal to 41, because the square root and square will cancel out. It's still equal to 41. So we need square for this 41. It's not a perfect square. So what I do is first I take square root, then I squared it. Okay, now instead of 41, we can write square root of 41 the whole square divided by x positive square root of 41. Now let's consider the expression we have over here. It's exactly in this form. At the place of a, we have x, and at the place of b, we have square root of 41. Okay, now we can write this one in factor form like this: a positive b times a negative b. Then we get x positive square root of 41 times x negative square root of 41 divided by, we can write the denominator as it is, that is x positive square root of 41. Now we can cancel this x positive square root of 41, x positive square root of 41. Then we get x negative square root of 41. This is a simplified form of the given expression. Okay, students, I hope the stuff which has been explained so far will be helpful for you to factor an expression with the difference of two squares. And for more digital SAT math content, keep watching our YouTube channel. And also you can go to the URL given over here to have more digital SAT math problems. Thank you.